Okay, so let's take a look at adding polynomials vertically and horizontally. So these are just two methods that you can approach when adding polynomials. It doesn't necessarily matter which one you use, whatever fits, works well with you. So let's take a look at the first one. It's vertical form. So say I have a polynomial expression, 5, okay, 5x squared plus 2x minus 1 and 4x squared minus x plus 2. And I was told to find the sum. Okay, so when they say find the sum, essentially what they're telling you to do is to take this polynomial expression, add it to this polynomial expression. Remember, the word and symbolizes an addition sign. So we're going to be adding both of these expressions. Since we're doing it vertically, I want to align the terms on top of each other. So I'm going to take the like terms and I'll start with my first expression, 5x squared plus 2x minus 1. And I'm just going to align them by like terms, meaning I know 5x squared is a like term with 4x squared because the variable and the exponent are the same. I can see that 2x and negative x, those are like terms, and -1 and +2 are also like terms. So for this second expression, I want to make sure that those terms are vertically aligned with the expression, with the first expression. So that means 4x squared goes under 5x squared, and that comes minus x plus 2. So this works out nice because these are both trinomials, and each term is a like term with the other expression. Sometimes it doesn't always work out that way. You'll see in another example that it won't be the case. So from here, we just want to add the coefficients, meaning I want to add 5 plus 4. That gives me 9x squared. Notice nothing changes with my exponent. Okay, now I want to do 2 plus -1. Remember, there's an invisible 1 right there. 2 plus -1 is just 1. And then I just bring down the x, and I can just call it plus x. And the last one is -1 plus 2, and that is just +1. Okay, and this is in simplified form. It's in standard form as well. I know it's in standard form because the term with the highest degree is first, and it goes in descending order. And this would be our solution after finding the sum. Okay, let's take a look at this example right here. We have 3y cubed plus 2y plus 1 and y squared minus 1. So we have these two polynomial expressions, and we're asked to find the sum. So if we're using the vertical method, let's first establish some like terms before we move forward. Let me take this first term of 3y cubed, and it doesn't look like there's a like term for that one, so I will just leave that be. Let's take a look at the second one. 2y doesn't look like there's a like term. Y squared is not a like term because there's no squared in this exponent over here. Okay, let's take a look at our next term from our first expression, +1, and -1 would be a like term, so we can align those vertically. And then the last one, y squared, is its own term. So if I'm going to align these vertically, let's go ahead and start with our first expression, and we will say 3y cubed plus 2y plus 1. And notice what happens when I try to align my second expression, the y squared. It really doesn't fit anywhere here, but if it were, it would have to be between the y cubed and then the 2y. So what I'm actually going to do now is just set a designated spot to fit that term. So I can also show that as saying 0y plus 0y, because 0 times y is just 0. So that's okay to write it that way. Or sorry, 0y squared. And now I'm going to add it to 2y. And then I'm going to add that to positive 1. Now when I take my second expression and I try to align it with this, well, I don't have anything to align with the y cubed or the 3y cubed, so I could just say 0y cubed, because 0 times y cubed is just 0. Okay, I'll say plus y squared. Oops, let's do a different color. Plus y squared. And I don't have anything to align with my 2y, so I'll just say plus 0y. And then the last thing I have to align is actually my negative 1, so I'll put minus 1. Now I can go ahead and add vertically 3y cubed plus 0y cubed. Well, this ends up being 0, so I'll just say 3y cubed plus 0y squared plus y squared just ends up becoming y squared. And then I have 2y plus 0y. Well, 0 times y is just 0, so it just becomes 2y. And then the last one, positive 1 plus negative 1 is just 0, so we could just say plus 0. And I'm just going to rewrite it over here as 3y cubed plus y squared plus 2y, and I don't have to include this plus 0 because that would be its simplified form. When you are aligning them vertically, it might help just to write it with the 0 so you're not confused when adding. Just like over here, I'm just going to put 0 instead so you don't get confused. And right here, this is also another method of aligning them. So you know that when you do 3y cubed plus 0 is just 3y cubed. 0 plus y squared is just y squared. 2y plus 0 is just 2y. But I wanted to show you why we have to keep those terms vacant, because when we're aligning them vertically, they all need to match up, so we are combining like terms. Okay, so for the second part of adding polynomials, we'll use the horizontal form. So let's take two polynomial expressions. Let's have 5x squared plus 2x plus 1. And we'll take negative 4x squared minus x minus 2. And again, we're asked to find the sum, meaning we're going to add both of these expressions together. But if we're using the horizontal form, we're going to do it slightly in a slightly different way. And what we want to do is we kind of want to regroup. So I'm just going to rewrite these expressions with parentheses. So the first expression, I'm just going to throw in some parentheses here. Instead of the word and, I'm going to have a plus sign. And the second expression, I'm going to throw in the parentheses. And what I want to do at this point is regroup my like terms. So I see 5x squared has a like term of negative 4x squared. I see 2x has a like term of negative x. And then I see positive 1 has a like term of negative 2. So from here, all I'm going to do is just group the like terms together within parentheses. So I have 5x squared, and I'm going to subtract that to negative 4x squared, even though I'm adding them. So be careful here. I am adding them, 5x squared to negative 4x squared, but I can rewrite it as 5x squared minus 4x squared. I could just drop the addition sign. Okay, and now I'm going to add it to my second regrouped like terms, which is 2x, and instead of 2x plus negative x, I'm just going to say 2x minus x. And I'm going to add that to my last one, which would be positive 1 minus 2. Okay, so let's go ahead and simplify. We have 5x squared minus 4x squared. I know just to add or subtract the coefficients, so that becomes 5 minus 4 is 1x squared. I'm going to leave the 1x just for now until I simplify at the very end, plus 2x minus x. Again, that just becomes 1x plus 1 minus 2. That becomes negative 1. And what I'm going to do is just simplify these by dropping the 1's in the coefficient. So it becomes x squared plus x. And right here, plus negative 1, that's the same thing as just saying minus 1. And that would be us finding the sum of these polynomial expressions. Okay, let's take a look at one more example. So let's say we have two expressions. We'll have negative x to the third plus 2. And let's say we have negative 4x cubed plus y plus x. Again, we want to find the sum, meaning we want to add these expressions together, and let's use the horizontal form to do this. So I'm just going to rewrite it as negative x cubed plus 2 plus negative 4x cubed plus y plus x. Okay, I'm just going to identify like terms. I see that this negative x cubed would be a like term with negative 4x cubed. And that is really it. Everything else, the 2 has no like terms, the y has no like terms, and x has no like terms. So what we're going to do is just regroup the negative x cubed plus negative 4x. I'm just going to say minus 4x cubed. And then the rest, let's just put that back in white, plus x plus y plus 2. And the reason why I wrote it like this, even though it goes 2yx, is that with alphabetically with variables, I like to go in ascending order. And I always put the constant, which is this 2. It's the basically a coefficient without a variable. I always put that at the end. Okay, so let's go ahead and simplify this expression right here. Negative x cubed minus 4x cubed. We can imagine an invisible negative 1 right here. So it's just like saying negative 1 minus 4, which is negative 5. Bring down the x cubed. Okay, and again, nothing else changes with these terms because we cannot combine them. So your final solution would be negative 5x cubed plus x plus y plus 2.